Good morning. I am Dr. M. Shaktivel, Professor of Artificial Intelligence and Data Science Department at Sri Shanmuga College of Engineering and Technology. In this video, I will be discussing frequency distribution and their graphs, a fundamental concept in statistics used to summarize and visualize data efficiently. Let's begin with the learning objectives. By the end of this presentation, you will be able to construct a frequency distribution that includes classes, frequencies, midpoints, relative frequencies, and cumulative frequencies. And then you can create and interpret frequency histograms, frequency polygons, relative frequency histograms, and ogives. These skills form the foundation for analyzing the large data sets and for visualizing statistical information clearly. Look at the table. We have two columns. First column is class and the second column is the frequency. This class contains 5 different classes or intervals. If you take the first column, the value is 1-4. The 1 is a lower class limit and 4 is the upper class limits. In the corresponding row, if you move to the next column, frequency column, the value is 4. This 4 represents these 4 values falls between the range 1 to 4. Each class in frequency distribution is defined by two boundaries. The first one is lower class limit, which is the smallest value in that class. The second one is upper class limit, which is the largest value in that class. These class limits help us to separate data into non-overlapping intervals. Next, let me understand class width and range. The class width is the difference between consecutive lower limits or upper limits of class. For in this table, the first value is 1 to 4. So the difference between this lower limit and upper limit. So the width is 4. Then the range is the difference between the maximum and minimum data entries or data values. Range gives us an idea about how to spread out the data, while class width tells us how to group the data. To construct a frequency distribution, we need to follow some guidelines. Here we have 3 guidelines. The first one is decide on the number of classes. Usually between 5 and 20 classes works well. Fewer classes may hide important patterns, while too many can make the table messy. The second one is find the class width. Compute the range of the data divided by the number of classes and then round up to the convenient number. And the third guideline is determine the class limit. Start with the smallest data value as the lower limit of the first class and add the class width repeatedly to find the next class limit. Let's look at an example. Suppose we have the ages of 30 students in a statistics class. The minimum age is 18 and the maximum is 54. So the range is the difference between the maximum entry and the minimum entry. So 54 minus 18. So we will get the value 36. We decided to have 5 classes. So class width will be the range divided by the number of classes. So 36 divided by 5. The answer equal to 7.2. So which we round up to 8. Using 18 as the lower limit of the first class, we can find the remaining class limits. So the lower limits start with 18. So we need to add 8. So 18 plus 8, 26. 26 plus 8, 34. 34 plus 8, 42, 50. Then upper class limits are 25. We start with 25 plus 8, 33. Then 41, 49 and 57. We then tally the data for each class and record the frequencies. The total of all frequencies should equal to the sample size. So in our example, we have 30 students. So all samples should be equal to 30. Now let's find the midpoint of each class. The midpoint is the average of lower and upper class limits. This represents the central value of that class. Mathematically, midpoint equal to lower class limit plus upper class limit divided by 2. So in our example, our first class lower class limit is 18 and the upper class limit is 25. So we add 18 plus 25 divided by 2. So 18 plus 25, 43 divided by 2, 21.5. So this is the 21.5 is the midpoint of first class. These midpoints value will be helpful when we draw the frequency polygon. Let me look into the example. We have 30 students age data. The starting age is 18 and the last or maximum age is 56. We have divided into 5 classes with the range of 8. So the first class range is 18 to 25, second one is 26 to 33, third class is 34 to 41, fourth class is 42 to 49, and the last class is 50 to 57. And we have the frequency count, the number of students within the class age. So 18 to 25 we have 13 students. Then 26 to 33 age we have 8 students. The count is here frequency. Then the third class we have 4 frequency count, fourth class we have 3 frequency count. For the last class 50 to 57 we have frequency count 2. So the summation of all frequencies should be equal to the number of samples or number of students. Next, the midpoint of a class is the sum of lower limit and upper limit divided by 2. So the midpoint is sometimes called as a class mark. So this midpoint is very helpful or useful when we draw the histogram polygon. So if we take our first example in our class, the class range is 1 to 4. So the frequency 4, then midpoint 1 plus 4. That is 1 is the lower class limit, 4 is the upper class limit. So 1 plus 4, 5 divided by 2. So the midpoint value equal to 2.5. Similarly, we have calculated the midpoints for the ages of students, the frequency distribution. So here we have totally 5 classes and frequency we have. So midpoint we are calculating 18 plus 25 divided by 2, 26 divided by 33 divided by 2, we are getting 29.5, 34 plus 41 divided by 2, 37.5, 42 plus 49 divided by 2, 45.5. 50 plus 57 divided by 2, 53.5. Relative frequency gives the portion or percentage of data that falls in that class. To find the relative frequency of a class, divide the frequency f by the sample size n. So relative frequency equal to class frequency divided by sample size. Sample size are total number of data values. So let me see the example. In our example already we discussed, this class range is 1 to 4. In this range we have frequency 4. Then now we need to calculate the relative frequency. We assume that we have 18 data and our sample size is 18. So our frequency is 4 divided by 18. So what is the portion or percentage of data falls in that class? So it is 4 divided by 18. We are getting 0.222, 22.2%. Similarly, find the relative frequency for our example ages of students frequency distribution. So the first class 18 to 25, we have 13 students. So our total sample data size is 30. So 13 divided by 30, we are getting 0.433. Then the next class 8, 8 divided by 30. Then third class 4 divided by 30. Then third class 3 divided by 30. It's very easy to calculate 0.1. Then the last one is frequency is 2. 2 divided by 30, 0.067. So the frequency count, so we have 30 samples. If we add all the frequencies, we should get the same number. So our total number of data equal to 30. This frequency also should be equal to 30. If we add this relative frequency, here we have not given any percentage, just we have given the points only. So the frequency divided by the total data. So we are getting the values. So if we add all this, we should get the total value should be equal to 1. Next, let me discuss cumulative frequency. Cumulative frequency of a class is the sum of frequency for that class and all the previous classes. For example, in our ages of student, we have 5 classes. In first class, we have 13. Second class, we have 18 frequency. Third class, we have 14 frequency. So suppose if you are considering the third class, so up to third class, what is the cumulative frequency? Then we have to add 4 plus 8 plus 13. So 4 plus 8, 12. 12 plus 13, 25 is the cumulative frequency up to class 3. So what is the meaning? So the number of students within or below the age of 41, we have 25. That is the meaning of this cumulative frequency.